this problem we have AB C. We want to calculate the deflections at point C. We want to calculate the slope at point C. And for this one, how do we know at the beginning what kind of directions will occur in each portion? Would that be only axial loading, or would that be additionally the bending in this portion? That is the first thing we have to justify.
Can you ignore bending since C is a rolling joint?
C is this constraint, meaning the whole at this point here is free to roll, but preventing from this way, and that means at this portion is free to tilt locally.
Yeah.
We're assuming this one. Basically, this one meaning is we fix everything here in linear displacement, but it's free to rotate. We might assuming is this. If we have go this way, then these things could be something moving in this way. If we would exaggerate the situation, then you can see this point, if we move into here, that's going to go down here. And the horizontal displacement, due to this constraint, will push C move forward.
Yeah.
But the vertical displacement at the B from here to here, that's going to cause the bending. Okay. Okay, if that one, this point go to the bending, maybe that bending will be influenced to this portion, might be. Who knows? Okay, so under these situations, and then also due to the reaction occurred here, so I would say for this case, it's more likely the bending will be more. Bending will be more, the more probability to occur than only the axial loading. Okay, for this case, the axial loading, I would say, is barely zero.
We're going to ignore axial from A to B?
Yes, so the strategy for this question, at the very beginning, I would say, I would write down my reasons, say, okay, after careful justification of something, then the strain energy for this question will be taking up this template. And for whatever the portion, how many here we have the two portions, so get the whole two portions.
And we can ignore any loading in BC.
In BC, you mean the
There's
axial loading?
no axial
yes,
loading there.
yeah. So that would be the reason before this statement, we just write it up, and then that is our assumption. And then I think that is usually that is the procedures. And then if down the road to the very end, the people say, well, your answer could be too conservative. I need you to relax your assumption. Then you, upon this one, you relax your assumption by adding or by considering axial loading or other type of the internal loading. Then you proceed another page of the calculation. That would be your second or revised the engineering report. Yes.
So to solve that, we would use the Castigliano's principle
Yes.
and the method 3
The method 3.
to solve for the strain energy,
And
then
then take.
Partial, then
Yes.
find the displacement, but to find theta,
Then to find the theta at C, because that has no loading, so we must assume additional virtual loading.
at C.
Yeah, so at C. So the type of the loading to produce slope will be moment. So the second step is we assume they would have the virtual virtual loading, let me call it N at C. Okay, this one is a virtual loading, so let me use the dash. And in our calculation, we have to set up MC equal to 0 at the proper step. So that's the thinking process. Okay, so we have the two loadings, P and MC, then we formulate the strain energy. We take the theorem to see. Okay. So now under these situations, we draw the free body diagram based upon what we have analyzed. For this case, this is
But that virtual like MC, you would have to so the whole thing is just that you would have to I guess like logic it out.
yes, because
What if you didn't what if you just didn't think about it? Like,
because why we want to introduce that one, because here will be allow us to take this one. Theta C, due to the Castigliano theorem,
Has to be
that can be
partial
calculated by this
moment.
one, right? But for this case, the MC is virtual assumed, so the value equal to 0. And this one we can use partial U, partial P. That's it. P is given. We don't have to take the 0 value there. Okay. So that is the one we're going to implement. Pretty much take the whole whiteboard and to do the calculation of individual terms. Yes.
Could we go through finding the theta C?
Yes, I will do it.
Oh,
Okay. So now for this case, we analyze the necessary information. And the first one is here we have to deal with the reactions. Assuming here we have reaction here is say RA, and here we have reaction from the vertical, say let me call that is RC. So 1, 2, 3, 4, that is a total loading we have to deal with. And the first one, we take the free body diagram to find out the RC and the RA. So here we take the force in, say, take a moment about point A. Okay, so the take a moment about A equal to 0. So that means here RC times L. So each side is L. Plus MC minus P plus Q. Where is Q? Oh, I made a mistake again. So you see, we're going to calculate diffraction at C, and here there's no loading, so we have to assume additional P here. So that is this is Q. And this one should be partial Q, and then Q equal to 0. Because we are not to calculate diffraction at B. So here we're going to focus on here. So we introduce the two different loading types corresponding to the two different degree of freedoms of the displacement. Okay. So that's a Q here. So there's a Q here. So this is equal to